Good day, everyone. My name is Maria Melvi Anino Suarez, and today our group will tackle about the file management. And we hope that at the end of this topic, you will learn about the logical and physical view of files, the role of the file management system, logical file access methods, physical file storage, file systems, volumes, disk, partitions, and storage pools, the directory structure, network file access, storage area networks, file protection, and the journalizing file systems. Based on the point of view of user, the file management system is one of the most important and visible features of the operating system because most user commands, whether typed into a command line interface or activated with a mouse or finger, are operations on files. There are many interactions between programs and the operating system are file requests. Even the database management application software requires the services of the file management system to perform its file storage and retrieval operations. So it is the file management system software that allows users and programs to store, retrieve, and manipulate files as logical entities. Terminology. First is the logical view. It is the contents and attributes of files viewed by the user. The second is the physical view. It is the actual way file is stored within the computer system. Third is the sequential access. It is the data files whose records have to be retrieved from the beginning. Fourth is the random or relative access. It is the data files whose record can be retrieved from anywhere in the file in random sequence. Fifth is the contiguous. It is the blocks that hold a particular file that are stored together. And lastly, the non-contiguous. The blocks that hold a particular file are scattered all over the device. So the first reporter that will discuss the logical and physical view of files will be yours truly. Logical and physical view of files. File is an organized collection of data, and block is typically 256,512 or 1024 bytes. It is where files usually require a 1 block minimum. Physically, the file on nearly every system is stored and manipulated as a group or blocks that are normally have fixed size, and when the blocks are grouped, it is called cluster. There are few examples of common forms of files. The first one is the program file. It consists of binary data, and the bytes of data in the file represent the sequence of instructions that make up a program. The second one is the data file. It consists of alphanumeric Unicode text that represent a program in source code form and will serve as data input to C++ compiler. And the third one is the directory file that consists of information about other files. So programs and videos are often stored as streams to be read serially one byte after another. A typical record-oriented file are called as the table image. In this illustration, each record is made up of the same fields, and each field have same fixed length for all records, but it is not necessary of all cases. This is the database file or called as form image. So in this illustration, the company personnel file does not require the salary for retired employees, and it uses a field of comments. And this figure show a file differently without affecting the record structure underneath. As another example, the program file mentioned earlier could be interpreted as a single record, single field, logical file with one long variable field in the record. Physically, the file could be stored as a sequence of physical blocks accessed one after another to retrieve the program. In addition to the data within the file, it is convenient to attach attributes to the file that identify and characterize the file. The most important file attribute is its name. The name itself may be specified in a such way as to allow identification with the particular type of file known as the file extension. And you can see example in window, its expanded name. A file may be executable as a program or readable as data. It may be considered as either binary or alphanumeric, might be temporary or permanent one, and can be writable or write protected. It also attributes as the date of origination, the most recent update, and information about who has the right to access, update, or delete the file. But some systems allow a data file to specify the program to be used with and called as an association. So file management system stored, controlled, and manipulated all the files together with the attributes and information that describe the files. The relationship between logical and physical records are shown in two illustrations. The first one is logical records and physical blocks unrelated. It shows that the file management system may pack the file into physical blocks without regard to the logical records. And the second one is the logical records stored one to a block. It shows that the file management system may attempt to maintain some relationship between the logical records and physical blocks. And to discuss with the role of the file management system, I will now give the floor to Ms. Sarte.
Good day everyone, I am Karen P. Sarte and I'll be reporting about the role of the file management system. File management system is commonly called as the file manager. It provides a logical view for the user and hides the physical implementation. Consistent set of commands are translated to a form appropriate for the device. Consistent view of files regardless of file type, file characteristics, or device. It also maintains directory structure for each device as the program requests are made directly to the manager. These requests commonly take the form of open, read, write, move file pointer, reset pointer to the beginning of file, or close and other similar procedure or function calls. The file manager checks the validity of the request and then translates the request into the appropriate physical course of action. As a specific example for this process, consider what occurs within the operation system when the user of a typical system types the command. So we have here the sequence of steps that takes place to make a file as a whole. We have copy, move. Second, we have list, print. Third, load and execute a program. Fourth, load file into memory. Fifth, store file from memory. Sixth, append data from memory to file. And last, compile, assemble a data. Operations can be divided into three different categories. So we have those that works on the enter file, those that operates on data within the file, those that actually manipulate the directory of the file. Examples of operations that work on the file as a whole are likely to be familiar to you as a user. So what are they? We have the copy of a file, load and execute a program file, store a file from memory, compile or assemble a file. Fundamental to every file manager, both stream and record-based, is the ability to manipulate the data within the file itself. The file manager provides a basic sets of operations that are used for this purpose. So those are open a file for reading or writing, read a number of bytes from the file, move the file pointer a distance forward or backward, rewind the pointer of the beginning of the file, close the file. A file management system that Provide support for individual record storage and retrieval, includes additional operations. So the following are the examples of record-based operations. We have read or retrieve a record, write or store a record, add a record to a file, delete a record from a file, and change the contents of a record. These operations that manipulates the file directory rather than the file itself. So we have delete a file, rename a file, append one file to another or concatenation. We have create a new file, move a file from one directory to another, the same physical advice. A file management system is directly responsible for all aspects of the maintenance of the file system. This requests to perform 5 major functions. So first, we have the file management system provides the connection between the logical file system with its physical implementation, allowing the physical view to remain essentially invisible. We have the file management system maintains the directory structure for each I/O device in use. Then the file management system supports manipulations of the data within the file. The file management system acts as an interface for the transfer of data to and from the various I/O devices by requesting transfers from the I/O device driver level of the operation system. And lastly, the file system manages file security and protection. So we have the two powerful advantages in separating the file and I/O function into different tasks. So first, we have the file system remains unchanged. Second, a command request to redirect the data is easy to implement since the file manager controls the file.
The third reporter that will discuss the logical file access method will be Ms. Salise.
Good morning, everyone. My name is Crystal May Salisi. There are 3 types of logical file access method. First is sequential access. File is read in sequence from beginning to end, referred to as a rewind. Next, information is simply processed in order of storage. Third, majority of all files. Fourth, program source and binary files. Fifth, some systems allow the pointer to move a fixed amount. It is called seek. Sequential access is based on a tape model since files only be read sequentially. Next, random access assumes file is made up of fixed length logical records. Next, file manager can go directly to any. Third, hashing is a common method used to calculate the location of an internal logical record. Hashing is based on some simple algorithm that calculates a logical record's number. 2 records calculate to the same number in order to prevent they store additional record in an overflow area. Last but not the least, indexed access. Additional means for accessing and viewing specific records in a file. Next, k-indexes. Third, large system provide additional access method. The most common of these is ISAM, which means index sequential access method. ISAM are kept sorted in order of a k field, and 1 or more additional index files are used to determine block. Lastly, used to expand capability.
The fourth reporter that will discuss the physical file storage will be Ms. Tadios.
Good day everyone, I am Josamine and Tadios and I will be reporting the physical file storage. There are 3 methods that are commonly used to allocate blocks of storage for files: contiguous, linked, and index storage allocation. One is non-contiguous linked index. Examples are DOS, Windows FAT, Unix, iNode, Windows NTFS, and free space management. And contiguous storage allocation. Under it are assigned blocks all in a row to hold the file. Access is simple for both sequential and random methods. There are also disadvantages of contiguous storage allocation, which are four. Number one is space must be large enough to to take into account file growth. 3 may need to remove if it outgrows space. 4 is fragmentation of disk. Also, allocation strategies to minimize fragmentation. First fit, best fit. Eventually, this becomes fragmented. Non-contiguous storage allocation, it helps the file system maintain a detailed orderly list of assigned blocks. There are two basic approaches to maintain the list of blocks allocated to each file. Number one is link allocation, which has non-contiguous. Each block contains a link to the next physical block. Variant links in both directions. There are also advantages of it. No fragmentation. Adding to a file is easy. Disadvantages, which is not usable for random access, additional disk head searching, overhead in storing the pointers, recovery of a defective block is difficult. Under the file allocation table, FAT is linked allocation with links stored in a table. Table contains the first block of each file on the disk or disk partition. Successive blocks contain link to the next block, which has also disadvantages, which you can see in the monitor. Requires a tremendous amount of space. File integrity can be easily compromised. Under it, you can see the picture which has file allocation table. Name of file, first block, block number denotes the end of the file or the directory. Let's move on to the second allocation, which is the indexed allocation. Non-contiguous, all link pointers for file are stored together in a single block called the index block. One index block per file. Advantages, which is no fragmentation, can be used for random access. Also disadvantages, slower due to additional access of the index block. Additional disk head searching. Recovery of a defective block is difficult. Below it is you can see the index block for indexed application of linked files shown, which has the strange date. Next is the Unix inodes. Is a index file allocation. Index block contains file attributes, 10 direct blocks, 1 single indirect, D, 1 double indirect, E, one triple indirect. This has also advantages, which are fast for small blocks, can accommodate very large files, 100s of gigabytes. Windows NTFS is a dynamically sized volume. Volumes may be fraction of a disk or span many disk. Master file table, MFT of 1 kilobytes records. First 16 records are metadata files, which describes the volume. First record stores the MFT attributes. Each file has an MFT entry, and file records made of attribute including the information on data. The picture that we're shown in your monitor is the NTFS volume layout, which has the NTFS metadata file records, which has 16 kilobytes, and also has the MFT attributes pointer to a copy of MFT attributes, log copy, volume file, attribution definition file, root directory, bad cluster file, and the user file and directories. Under it is the space for non-resident attributes, which also has master file table. Resilient file system is a larger and more powerful file system. Works similarly to NTFS but is more flexible and scalable. Below is the resilient file system table structure, which you can see in the monitor. Free space management is a bitmap method. 1 bit for each block to indicate if it is used or free. Linked list method pointers to first free block. Each free block has a pointer to the next. Blocks are allocated from the beginning. Deleted files are placed at the end. You can also see the picture above, which has free space bitmap block numbers, which range for 0 to 15, 16 to 31, 32 to 47, 48 to 63. Other secondary storage allocation has also this tape allocation, not practical to reallocate space in the middle of the tape. Files that grow must be rewritten. Files are stored contiguously whenever possible. CD, DVD, and flash drive allocation is similar to that. Hard disk UDF, which means Universal Data Format, supports up to 2 terabytes of data. Hierarchically directory format, support for both HD, DVD, and Blu-ray DVD formats.
The fifth reporter that will discuss the file systems, volumes, disk, partitions, and storage pools will be Ms. Soji.
Now, here are the file systems, volumes, disk, partition, and storage pools. First, let us tackle the file system. It hides all storage details. A file system is a set of data structures, interfaces, and abstraction that work together to manage any type of file on any type of storage device in a consistent manner. Let us move to the file management. It is the process and act of creating organized structures in which you store informations for easy retrieval. So next is the virtual file system, a concept of separate file system. It is an abstract layer on top of a more concrete file system. We have here also the partition, which is the independent section. A partition is a logical division of hard disk that is treated as a separate unit by operating system. So let us proceed to the volume, which is called the file system. In computer data storage, a volume or logical drive is a single accessible storage area with a single file system. Another one is the volume table of contents. It is called to the directory and is the list of files on a disk. That is why it is necessary to mount a volume device of partition before it can be used. Lastly is the mount point, characterized as mounting a volume. A mount point is a directory or file at which a new file system, directory, or file is made accessible. We are done with the discussion of their uses and definition. Now, moving forward to the diagram presented. As an example, an inexpensive desktop computer might have a single disk and a CD drive or DVD drive by default. Windows would treat this simple configuration as two file systems, one for each disk, probably labeled C and D respectively. In this situation, each disk has a single file and directory system logically facing the user and a single 1.0 interface facing the disk controller for each device.
The sixth reporter that will discuss the directory structure will be Ms. Iban.
I am Kathleen Bianca Iban, and I will now be continuing our report. So, directory structure. Directory structure provides a means of organization so that files can be located easily and efficiently. Directory structure hides the physical devices from the logical view of the files. It has partitions, and the structure has independent subsections of a device. It has volume, and the directory structure is for a particular partition. It needs to be mounted to be incorporated into the overall file system structure. It contains file attributes. Shown on the right side of the screen, there's the typical file attributes, which are the name and extension, the type, size, maximum allowable size, location, protection, name of owner, name of group, date of creation, date of modification, and the date of last use. Next is the disadvantages. The user cannot organize his work. It is possible also to destroy a file, and a single-level directory is unsuitable for a system with multiple users. So, the directory is only compatible with a system that has only one user. Next is the tree-structured directory or the hierarchical directory, which is still under the directory structure. Hierarchical with the top-level root directory from which all other directories stem. All directories and files have names under this directory. It has elements, namely the separator, the path name, and the search paths. Separator is used to indicate subdirectories and files located in a directory. Examples of the separators are Unix, DOS, and the Windows. Path name has two types, which are the absolute and the relative. Absolute is defined as the full path name starting from the root directory, while the relative is defined as the path name that is created starting from the current directory. And lastly, the search paths. It is where the directory locations that the operating system uses to locate files. Now, an example of a tree-structured directory is shown on screen. The tree structure is characterized by a root directory which is found on the top, from which all the other directories stem. On most systems, the root directory contains few, if any, files. In the illustration shown, there are two files, which is the config.sys and the autoexec.bat. The root directory is stored in a particular location known to the file system. Other directories are themselves stored as files with a special purpose. This means that directories can be manipulated by the system like any other file. Next is the acyclic directory structures. It is a tree structure that permits links between separate branches of the tree. Its advantage is that it is an easy user access, and disadvantage is that the cycles and the dangling links. Examples of the acyclic directory structures are the Windows shortcut, the Unix hard and symbolic links, and the Macintosh links, or the aliases. To the right side of the screen, there is an illustration. It is an example of an acyclic graph directory. Here's another diagram, which is the graph with a cycle. One difficulty with implementation of an acyclic graph directory is assuring that the links do not connect in such a way that it is possible to cycle through a path more than once when tracing out the path to a file. The system must assure that the addition of a link does not create a cycle. On the next figure, a hard link points from a new directory entry to the same inode as another directory entry somewhere in the file system. Since both entries point to the same inode, any changes made in the file are automatically reflected to both.
The seventh reporter that will discuss the network file access and storage area networks will be Ms. Villafranca.
What is network file system? Network file system is a networking protocol for distributed file sharing. A file system defines the way data in the form of files is stored and retrieved from storage devices across network. NFS protocol specification was first published by the Internet Engineering Task Force as an Internet protocol in 1989. How does the NFS work? He has NFS server software installed, and he has at least one network connection for sharing NFS resources and accept and respond to NFS requests over the network connection. NFS services. The NFS services needs the remote procedure call service running to work. NFS should only be started after remote procedure call. Standard option: start, stop, restart, status. Network file system was developed in 1984. NFS is a client-server application. A computer user view and optionally store and update files on a remote computer, allowing user on a client computer access files over a computer network like local storage is accessed. NFS is a file system used for sharing of files over a network and other sources like printers, and storage devices can also be shared. This means that using NFS files can be accessed remotely. Purposes of NFS. NFS can be stored on a single machine, can be used for sharing or files remotely, and still remain accessible to others over the network. What is storage area network? Storage area network is a network of storage devices that can be accessed by multiple server or computer providing a shared pool of storage space. Each computer network can access storage on the SAN as to they were local desks connected directly to the computer. An example of SAN first, the Fibre Channel or FC is commonly used in enterprise environment. Ethernet system connecting a local area network with protocols to control the information and avoid simultaneous two or more systems. InfiniBand is a channel-based fabric and facilitates high-speed communication between interconnected nodes. This is the uses of SAN. This is used to access the data storage devices such as disk arrays and tape libraries from server to the devices appear to the operating system as direct attached storage. Dedicated network of storage devices is not accessible through the local area without LAN. Be the end of my report. Thank you.
And the last reporter that will discuss the file protection and journalizing file system will be Ms. Timbal.
Pleasant morning to everyone, especially to Ma'am Karen Labor. First and foremost, let me introduce myself. I am Mary Timbal, and this juncture, I will discuss about file protection and journalizing file system. So what is file protection? File protection, it may prevent programs from replacing critical Windows system files. Passwords could provide us the first line of defense against unauthorized access to your computer and personal information. And the most system provide three forms of protection and files. RED protection. What is RED protection? RED protection is a RED protection status that can display in your computer when maximum protection is not ensured on your computer. Second is write protection. What does write protection mean? Write protection is the term used to denote the locking mechanism which prevents modification or deletion of data on a storage device. Third is execution protection or data execution prevention. It is the security feature that can help to prevent damage to your computer for viruses and other security threats. Next is Access Control List or ACL. So control list, it was the list of users who may access the file of each of the forms of protection. And tremendous overhead if there is a lot of users. So access control list, it was the list of rules that specifies which users or systems are granted or denied access to a particular object or system resource. So, access control list can help us to organize traffic, to improve network efficiency, and to give network administrators granular control over users on their computer system and networks. And then owner group and everyone protection method, Unix and Linux. The journalizing file system. So, the journalizing file system, it extended protection in order to automatically recover file from disk crash or system failure. Also, the journalizing file system log file records that every system transactions that requires a write access to a file system. So, it has two levels of capability. First, to protect the integrity of a file system structured only. For example, is Windows NTFS file system. Second is also guarantees the integrity of data that has not yet been written to the disk. For example, is Linux Extended or IBM and GFS. So in terms of failures, journalizing file system may help us to prevent or to rewritten the operating system that can use the lag to repair them when the computer is restarted.
Again, the reporter of Chapter 17 about file management are the following. The first reporter was yours truly, Maria Melvi Aino Suarez. The second reporter was Karen P. Sarte. The third reporter was Crystal May Salise. The fourth reporter was Jessa May Tadios. The fifth reporter was Minami O. Shoji. The sixth reporter was
Kathleen Bianca Iban, followed by
Rosemary H. Villafranca. And but not the least reporter was Mary Timbal. And that would be all. Thank you.